Hello students, welcome to AIMS India online classes. This is a chemistry session. In this, we are discussing about the chapter atomic structure. In this session, we are going to say about atomic number and mass number and the terms related to the comparisons between the fundamental particles of different atoms. First about atomic number. Each element has been assigned with an atomic number, the number of protons present in the nucleus of an atom. So, the number of protons present in the nucleus of an atom is considered as the atomic number of that element. So, for every element, the number of protons present in the nucleus will be unique. So, this number of protons is considered as its atomic number. The number of protons in the nucleus of an atom determines the identity of the atom. Yes, as I told, for every element, the number of atoms in its atoms, number of protons in its atoms will be fixed, unique. So based upon these number of protons present in the nucleus, its identity will be different from the remaining all. It will be having some particular properties. So atomic number is equal to number of protons. For any element, number of protons gives its atomic number. For neutral atoms, number of protons is also equal to number of electrons because the total number of positive charges is equal to total number of negative charges, that is electrons, in a neutral atom. So the atomic number is also equal to number of electrons if in the case of neutral atoms, but it is always equal to number of protons. So it is fixed because number of protons won't be changed for any atom, even the chemical reactions also. But often number of electrons will be changing. Sometimes atoms may they lose electrons, and even sometimes they may share electrons, even they may gain electrons. So number of electrons might be changed. So when they gain or lose electrons, they form ions, charged particles. In that case, number of electrons is not equal to atomic number. So number of electrons is equal to atomic number only in the case of neutral atoms. But it is always equal to, atomic number is always equal to number of protons. And this atomic number is denoted with capital Z. The symbol is capital Z. Next, mass number. It is the total number of protons and neutrons present in the nucleus of an atom. So it is called mass number. Mass number is taken as the sum of the protons and neutrons. The total number of protons and neutrons present in the nucleus of an atom is considered as its mass number. So protons and neutrons present in the nucleus of an atom are collectively called as nucleons, isn't it? Because they are present inside the nucleus. So as these particles, protons and neutrons are present inside the nucleus, they are specially called nucleons. Now we can say atomic mass number of an atom is also known as nucleon number. Nucleons are nothing but protons plus neutrons. And this mass number is denoted with the symbol capital A. So mass number A is equal to number of protons plus number of neutrons. The sum of these two gives mass number of an element. So the number of neutrons in an atom is equal to the difference between the mass number and atomic number. Why? Because as we have seen here, atomic number is nothing but number of protons, and mass number is the sum of the protons plus neutrons number. So if you take the difference of these two, we get the number of neutrons in that atom. So it can be written equationally like this: number of neutrons n is equal to mass number, that is neutrons plus protons, whereas atomic number represents only number of protons. So number of protons plus number of neutrons plus number of protons minus number of protons. Finally what we get? Number of neutrons. So number of neutrons can be simply calculated by using the formula mass number minus atomic number. Okay. It is to be noted that all the three quantities, what are they? Atomic number, mass number, and number of neutrons. These three are positive integers. There won't be any negative numbers or fractional numbers, because just these are the numbers which are indicating number of protons and number of neutrons present in the nucleus of the atom. There won't be any half or fractional values. So they will be always positive integers. The atomic mass of an element corrected to the nearest whole number is its mass number. So atomic mass is about mass of one atom of an element. It might be in some fractions also. But mass number is the corrected value of this atomic mass. For example, if you see here, atomic atomic mass of phosphorus, or the mass of one atom of phosphorus, is 30.975 atomic mass units. Here, this AMU represents atomic mass units. It is one of the smallest units of matter, as we know. So in AMUs, mass of one atom of phosphorus is equal to 30.975. The fraction value in decimals we are getting here. So the same value, if it is corrected to nearest whole number, that gives its mass number. So mass number of phosphorus is equal to 31, because for this the nearest whole number is 31. So this represents number of protons plus number of neutrons present in the nucleus of phosphorus atom. So always mass number is a whole number and it is a positive integer, because it is representing the number of fundamental particles. Okay. Next, representation of an atom. By using these atomic numbers and mass numbers, we can represent an atom. The most accepted way to denote the atom of an element X is ZXA. See here, generally atoms are represented in this way. Here, X represents the symbol of that element, and Z is which is written at the subscript. At the left side subscript it is represented. This Z represents atomic number of the element, and A, which is written at right side superscript, that represents mass number of the element. So in this way, generally elements or atoms are denoted by using symbol, atomic number and mass numbers. Okay. Always atomic number is written at the subscript side. Generally left hand side subscript position it is written, and mass number is written in the superscript. Generally we write at right side. It may be represented in often at the left side also, but in the superscript we represent mass number. Okay. For example, the atomic number of carbon is 6 and its mass number is 12. That means it has 6 protons, and it has 6 protons and 6 neutrons in the nucleus. So number of protons plus neutrons is its mass number. So its mass number is equal to now 12, and its atomic number is 6. And its a symbol of carbon, as we know, it is C. Now how can we represent this atom of carbon by using the symbol, atomic number and mass number in this way? C 6 12. Here, this is C represents the symbol of carbon atom, and 6 represents atomic number of carbon, whereas the number 12, which is written at the superscript, this represents mass number of carbon. Okay, in this way, atoms of elements are denoted by using symbol, atomic number and mass numbers. So, based upon the number of fundamental particles present in the atoms, different atoms of elements are compared one to another. So let us see those comparisons now. Out of those, the first one is isotopes. The atoms of an element which are having same atomic number but different mass numbers are called isotopes. So what is the definition for isotopes? The atoms of an element. So from an element, if you collect the atoms, out of those, they will be having same atomic number. Atoms of an element are having same atomic number all. But sometimes their mass number might be changed because of the number of neutrons difference. So anyhow, the atoms of an element which are having same atomic number but different mass numbers are called isotopes. For example, hydrogen gas has three isotopes, namely protium, deuterium, tritium. These three are isotopes of hydrogen. See, diagrammatically you can represent like this. So the first one, protium, which is having, so this number which is written in the superscript represents atomic number, means number of protons. So number of protons is 1 and around that one electron is revolving. This is protium. It has no neutrons if you observe. And deuterium is having atomic number 1 but mass number 2. It is changed here. Atomic number is being same 1 and 1 but mass numbers are changed. For the protium it is atomic number mass number 1, whereas for deuterium mass number is 2. This difference is because of the number of neutrons difference. If you observe protium, it has no neutrons here, isn't it? Whereas if we come to this, there is one neutron in deuterium. So the sum of these two, protons plus neutrons, gives its mass number. So mass number of deuterium is 2. Okay. If we go to tritium, tritium atomic number is 1, but mass number is 3. That means it has 2 neutrons, whereas only one proton. So for this all, if you observe, number of protons is same. That means atomic number is the same. So, but if you observe number of neutrons being varied, hence they will be having different mass numbers. So such kind of atoms of an element which are having same atomic number but different mass numbers are called as a isotopes. So these protium, deuterium, tritium are called isotopes of hydrogen. Where these are being differed? In the number of neutrons in the nucleus. Normally existing hydrogen in the atmosphere is called protium. The large quantity hydrogen available is called protium. It has no neutrons, only one proton in the nucleus. Around that, one electron will be revolving. Okay, this is about isotopes of hydrogen. Let us see one more. Carbon element. Element carbon also has three isotopes. They are namely carbon 12, carbon 13 and carbon 14. So these three are the isotopes of carbon. Where they are getting differed, all they are having same number of protons in their nucleus. That means atomic number is same. But if you observe, number of neutrons are being varied. First one has 6 neutrons. Carbon 13 has 7 neutrons. Carbon 14 has 8 neutrons. So as the number of neutrons are being changed, their mass number is changed. They have same atomic number, but mass numbers are different because of the difference in number of neutrons. Such kind of atoms of an element which are having same atomic number but different mass numbers are called as the isotopes. So isotopes of carbon are three: carbon 12, carbon 13, carbon 14. Out of these, mostly existing carbon is carbon 12 in the nature. Remaining two are rarely existing. Just like for hydrogen, how it is protium available mostly. Here for carbon also, carbon 12 is mostly existing. Remaining two are rarely existing. Okay. Next, one more example. In the same way, chlorine has two isotopes. Yes, even chlorine also having two isotopes. Chlorine occurs in the nature in two isotopic forms, with masses or mass numbers 35 and 37 in the ratio 3:1. Yes, chlorine also having two isotopes. One chlorine has mass number 35, whereas other chlorine is having mass number 37. So out of these two, chlorine with mass number 35 is existing or available in the more quantity. Around 75% is with mass number 35. Remaining 25% chlorine available in the nature is with mass number 37. So here also this difference in the mass number is due to the difference in their number of neutrons in the nucleus. See, number of protons are being same, number of electrons are also same, only difference in number of neutrons, so that they're getting difference in their mass numbers. Okay, next. So as we have seen here, for some elements there are isotopes. Different elements are having different isotopes. Hydrogen has three isotopes, and carbon also having three isotopes. Even we have seen at last phosphorus is also, chlorine also having two isotopes. Obviously, we may get one doubt here. What should we take as a mass of chlorine atom? We say Hussein two isotopes of chlorine, one with mass 35 units, the other with mass 37 units. So now to say generally for chlorine what is the mass of chlorine atom? So let us find it now here. The mass of an atom of any neutral element is taken as the average mass of all the naturally occurring masses of that element. Okay. Generally, mass of the atom, generalized mass of the atom is considered as the average of the masses of the all atoms occurring for naturally occurring atoms for that element. If an element has no isotopes, then the mass number of its atom would be same as the number of protons plus neutrons number. That is nothing but nuclear number. So if an element, if it is having no isotopes, all are having same number of protons or neutrons in their nucleus, then that number itself it will be taken as mass number. That means if an element, if it is having no isotopes, then mass number of that element will be considered as a mass of that atom. Okay, mass with the units will be considered. But if an element occurs in isotopic forms like hydrogen or chlorine or carbon, if an element, if it is having isotopes, then directly mass number of any one of those cannot be taken as its atomic mass. We cannot take directly mass number because more than one kind of mass numbers are available. Then atomic mass cannot be taken directly mass number. Then we have to know the percentage of each isotopic form which is available in the nature, and then the average mass is calculated by using one formula. Okay, if an element, if it is having more than one kind of isotopic forms, then if we know the availability of those isotopes in the nature by using those availability percentages and their mass numbers of different isotopes, we can calculate its average atomic mass by using one formula, that is average atomic mass is equal to mass number of one isotope into its abundance plus mass number of second isotope into its abundance, and if there are more than two, then we will be continued that mass number of third isotope into its abundance divided by total abundance. This gives the average atomic mass of that element. So just now we have seen chlorine has two isotopes. Chlorine with mass number 35, which is available around 75% abundance. Okay, chlorine 35 is available 75% in the nature, whereas chlorine with mass number 37 has 25% abundance in the nature. So we know now mass numbers of two isotopes and their percentage abundance also we know. Now we can calculate the average atomic mass of chlorine by using the above formula here. What can we do? Mass number of first isotope. What is the first isotope mass number? 35. So let us substitute that. 35 into what to be multiplied into its abundance. Its abundance is 75%. So mass number of first isotope 35 into its abundance 75 plus mass number of second isotope, that is 37, into its abundance 25%. Total abundance means sum of these two. How much we get? 100. Now if you simplify this, we get it as 35.5. Now we can say average atomic mass of chlorine is 35.5. I hope you understood why chlorine atomic weight is written in fractions now, because it has different number of isotopes. If an element is having more than one kind of isotopes with a considerable abundance, then its average atomic mass or atomic weight is calculated by using the formula mass number of first isotope into its abundance plus mass number of second isotope into its abundance divided by total abundance. In this way, chlorine is getting its average atomic mass as 35.5 units. So the same we can say as atomic weight of chlorine is 35.5. So atomic weight is nothing but average atomic mass. It might be in fractions or decimals, but mass number will be always a whole number. Okay. Next, one more comparison between the atoms, that is isobars. The atoms which are having same mass number but different atomic numbers are called isobars. What is this? Actually, these are atoms of different elements which are having same mass number. Means same number of nuclei in their nuclei but different atomic numbers are called isobars. Let us see one example so that we can understand easily. For example, argon and calcium are isobars. Let us see about their number of fundamental particles. We say elements argon and calcium, their atomic mass is 40 and 40. Both are having same atomic mass, but their atomic numbers are 18 and 40. Argon atomic number is 18, whereas atomic number of calcium is 20. Both are having different atomic numbers, but they have mass numbers same, 40 each. This is, of course, this is due to the different number of neutrons. Argon has 18 protons, whereas 22 neutrons there are present. 22 neutrons are present in argon. Whereas if you see calcium atom, it has 20 protons and 20 neutrons. Both are different here. Number of protons, number of neutrons are different for these two atoms. But the sum of the nucleons, total it is 40. Nothing but mass number. Both are having mass number in common, same. They have different atomic numbers, but mass numbers are being same. This kind of atoms are called isobars. Atoms with the same mass number but different atomic numbers are called isobars. Okay. Next, isotones. Atoms of different elements having same number of neutrons are called isotones. These isotones will be having different atomic numbers, different mass numbers. Only they will be having in common number of neutrons same. For example, if we see silicon and phosphorus, these two are isotones. If you observe, they have atomic numbers different. For silicon it is 14, for phosphorus it is 15. But even mass numbers are also different. For silicon mass number is 30 and for phosphorus mass number is 31. They have different atomic numbers and different mass numbers, but they have number of neutrons same in both. If you observe number of neutrons in silicon, How to calculate number of neutrons? Number of neutrons is equal to mass number minus atomic number. For new silicon, if you observe, mass number is 30, atomic number is 14. So what do we get? 16 neutrons. So number of neutrons in silicon is 16. Whereas if you observe for phosphorus, mass number is 31 and atomic number is 15. So here also we get same number of neutrons in phosphorus also. So like this, the atoms which are having different mass numbers and different atomic numbers, but they have number of neutrons same, then those atoms are called isotones. Okay, atoms with the same number of neutrons but different atomic numbers and mass numbers are called isotones. Next comparison, isotopic number. This is the difference between the number of neutrons and protons of an atom. Isotopic number is defined as the difference between the number of neutrons and protons of an atom is called its isotopic number. Okay. For example, isotopic number of carbon is, how to calculate? Just by taking the difference between the number of protons and neutrons of this atom, we can say its isotopic number. If you see for carbon, mass number is given 12 and atomic number is 6. The difference between these two, the difference between the number of neutrons and protons of an atom is called its atomic number. Now, mass number of carbon is given as 12, isn't it? And what is atomic number given? 6. Now, can we calculate the number of neutrons of carbon? Yes, we can, because we have a formula, mass number minus atomic number gives its number of neutrons. So mass number is 12 and atomic number is 6. So what is the number of neutrons now? 6 neutrons. Now the difference between the number of neutrons and number of protons of this atom gives its isotopic number. Now let us calculate its difference between number of neutrons and protons for carbon. It is 6 minus 6 because both are 6 here. So as there are same number of neutrons and protons, its isotopic number is 0. Okay, hope you understood. Isotopic number means the difference between the number of neutrons and protons of an atom is called its isotopic number. One more example let us see here. Isotopic number of sodium. So how can we calculate? First we have to find out the number of neutrons of sodium. How can we calculate number of neutrons? Mass number minus atomic number. So 23 minus 11. So number of neutrons is 12 for this. And proton number is nothing but its atomic number, that is 11. Now, what is the isotopic number of sodium? Number of the difference between the number of neutrons and protons. That is 12 minus 1. We get it as 1. So isotopic number of sodium is 1, whereas for isotopic number of carbon is 0. Okay. So isotopic number gives the difference between the number of neutrons and protons of an atom. Next, isodiaphers. The nucleides which have same isotopic number are known as isodiaphers. So just now we have seen isotopic number. The difference between the neutrons and protons of an atom is called isotopic number. The atoms which are having same isotopic number are called as isodiaphers. For example, thorium and uranium. If we take these two are isodiaphers because they have same isotopic number. If we say isotopic number of thorium, how do we get? Its number of neutrons. If you subtract this 90 from 234, we get its number of neutrons as 144. And its atomic number or number of protons is 90. So we get the difference between the number of neutrons and protons as 54. If we see the same difference between the number of neutrons and protons for uranium, there also we get 54. So like this, the atoms or ions or molecules, whatever they are called simply nucleides. The atoms which are having same isotopic number are called as isodiaphers. Okay, next, isoelectronics. Elements or ions or molecules or any other species which are having same number of electrons with them in them are called isoelectronics or isoelectronic species. Okay, the species which are having same number of electrons are called isoelectronic species. They might be atoms or ions or molecules, whatever they might be. If they have same number of electrons, then they are called isoelectronics or isoelectronic species. For example, Na plus and neon and even F minus, these three are called isoelectronics because if you observe for these three number of electrons, generally for sodium there will be 11 electrons, but it is mentioned here Na plus means it lost one electron, so number of electrons in Na plus is 10. We know atomic number of neon is 10 and it has 10 electrons. What about fluorine? Atomic number of fluorine is 9. It will be having 9 electrons, but it is mentioned here F minus ion means it gained 1 electron. Total number of electrons in F minus now becomes 10. So these three are having same number of electrons. So these are called isoelectronics or isoelectronic species. Okay, they might be atoms or ions or molecules, whatever they might be. If they have same number of electrons, then they are called isoelectronics. Okay, next, one more example if you see here. We told they might be molecules also. So CO2 and N2O, they are called carbon dioxide and nitrous oxide. This nitrous oxide is also called as laughing gas, as we know. So laughing gas and carbon dioxide, these two are having same number of electrons. So these two molecules are called isoelectronics. If we calculate number of electrons in carbon dioxide, carbon has 6 electrons, each oxygen has 8 electrons. So 8 to just 16 plus 6, 22 electrons totally in carbon dioxide molecule. In the same way, if you observe for nitrous oxide, which is called laughing gas, for this also total number of electrons. Each nitrogen has 7 electrons, so 2 nitrogen 14, and one oxygen atom has 8 electrons. Total it becomes 22 electrons. So in this way, these two molecules are having same number of electrons in them. So these are called isoelectronics or isoelectronic species. Okay. Next one, isostars. Isostars are the molecules or ions with the same number of atoms and same number of electrons. So the atoms or ions which are having the molecules or ions which are having same number of electrons as well as same number of atoms in them are called isostars. For example, just now you have seen one example there in the isoelectronics, carbon dioxide and nitrous oxide. These two molecules are having same number of electrons in them, each 22. And also they have same number of atoms. If you observe, carbon dioxide molecule has 3 atoms, one carbon atom and 2 oxygen atoms. And if you observe nitrous oxide, 2 nitrogen atoms and 1 oxygen atom, totally 3 atoms here also. So number of atoms is same, and number of electrons also 20 to 22, it is also same. Like this, the molecules or ions which are having same number of electrons as well as same number of atoms are called isostars. Okay, these are the different relations between the atoms of elements based upon the number of fundamental particles existing in them. Okay, thank you for watching our video. Please subscribe our YouTube channel AIMS Today for latest updates and recorded videos. Thank you.